Good morning and good afternoon, everyone. And thank you for joining us today for our webinar entitled DevSecOps for Container-Based Environments. We are going to discuss in as much as we can in 1 hour about securitizing your container-based environments. Thank you for joining us again. My name is Dennis Bruce. I am the Managing Director of the 3XM Group. Today's webinar is presented by the Technology Association of Georgia, and we have guest speakers from the Weather Channel and the 3XM Group, experts in security and in cloud-based environments. Today we are sponsored by Dynatrace, and we are grateful to them for their sponsorship. Our guest speakers today will be Dorren Schmitt, Senior Director of Technology Infrastructure for the Weather Channel. And our expert panelist will be Alexis Cuadrado, Cloud Practice Lead for the 3XM Group, along with Alfredo Pardo, our Senior Security Architect, also from the 3XM Group. As mentioned, today's sponsor is Dynatrace. Representing Dynatrace today is Dave Foreman, Account Exec. I will turn it over to Dave to speak a few words about Dynatrace. Dave?
Yep. Thank you, Dennis. Hi, all. I'm Dave Foreman with Dynatrace here in Atlanta. Dynatrace has been an APM provider or application performance management provider for a while, so a lot of folks know us, but a lot's changed in the recent years. So to give you an update on our solution, it's an all-in-one platform that monitors and analyzes your application performance, your infrastructure, digital experiences, and it adds to that digital business analytics and AI ops. And all of this is built on a patented AI core that proactively finds issues, determines root cause, and that's down to the code level, showing the business impact of the users that are impacted, and can even trigger auto remediation. So the benefits to our clients is they're able to do more with less resources by first simplifying operations with automation and self-discovery. And this is especially impactful in the dynamic environments of microservices and containers we'll be talking about today. And second, and more from that business viewpoint, it's about cutting through the noise so you can focus on improving experiences and outcomes. And we can do that because it is that all-in-one platform. So we have a single source of truth, for all the groups. And third, and for DevOps, probably more relevant for this group today, it's about building better software faster by shifting left to build quality and automation of your CI/CD pipeline. I mentioned the auto remediation, and shifting right to bake resiliency into the code pack. And so just to kind of maybe give you another way to look at Dynatrace, when our clients engage us, some of the things that kind of come up or they ask for or they're struggling with are things like, I hear things like, hey, we're looking to proactively find issues in our, we've got a complex hybrid environment, and kind of to put that another way, it's embarrassing when, or it doesn't work for us to find out from the users. We want to know first, right? Obviously, something else that people bring to us is, hey, we're adopting microservices and containers, and we recognize that brings a new level of complexity, and we don't have the capability to monitor or instrument that. Or we're looking to improve user experience. Maybe we're lacking visibility into some of our business critical applications. And for those that are maybe further down the maturity path, it may be that, hey, we're ready to take the next step because we're moving toward autonomous operations. So those are the kind of things that, we would certainly, if you're grappling with those, we'd be excited to learn more and explain how Dynatrace can help. So thank you, Dennis. Back to you.
Thank you, Dave, and thank you for that, those words from Dynatrace. Back to the webinar. As the name implies, we'll be discussing securitization and the implications of deploying containers, areas of potential vulnerability, do's and don'ts related to container deployment, and any concerns our audience has in relation to securitizing container-based environments. So we do urge you and suggest that you do submit your questions in the Q&A section. Please feel free to do that. There's quite a bit to cover regarding this topic, and we understand that 1 hour may not be enough time to cover what we have planned to discuss, along with some of the concerns from the audience. We'll be happy to take any questions that we can't address today offline, individually, and I'll leave my contact information for that purpose. I would also like to mention that we at the 3XM Group will be offering for our audience, for those participating today, a free cloud security assessment. No obligation. I'll leave my contact information so that we can get that arranged for you if you so desire. Otherwise, we can take just a call or answer questions through email that you may have regarding some of this, this content and the topic that we're discussing today. Dorren Schmitt, Senior Director of Technology Infrastructure for the Weather Channel, as mentioned, will be leading a discussion with our team leads, Alexis and Alfredo, providing the technical guidance. So right now, let's just get right into it. Let me introduce Dorren Schmitt, Senior Director of Technology Infrastructure for the Weather Channel. Dorren, all yours.
Hello. Hi, everyone. Happy afternoon. As board chair also of the DevOps Society, I would like to welcome everybody who's on this webinar. I also want to recognize a society sponsor of Cumberland Group that has been our society sponsor for over 5 years. And they provide professional services on the security side, infrastructure, backups, cloud, you name it. You know, they are an excellent partner with companies around the city in particular, but also branching out into larger in Georgia and also down in Florida. And so I want to recognize them. You know, today we're going to talk about containers. It is, if you think about it, you know, old becomes new and new becomes old again. If you were back in IT, back in the early 2000s, we talked about containerization under operating systems such as Sun Solaris, where you had various applications running on the same OS, but containerized. We got away from that with a lot of virtualization, and lo and behold, about 20 years later now, we're talking about containers again in a brand new context and in a much, much broader scale. And so I want to toss to Alex for a minute and talk a little bit about how popular containers are becoming before we get to our first question.
Thank you, Dorren, for that introduction. It's a pleasure to be here. Thank you for everyone who has joined this webinar. Yeah, containers have become extremely popular over the last few years, and they have certainly changed the way in which we architect and deploy applications nowadays. And like you said, all becomes new. The concept of containers isn't really anything new. I mean, it dates back all the way to Unix's chroot, which was this system call for changing the root directory of a process. With the idea of providing an isolated disk space for each process. Obviously, the concept has evolved. And since Docker, I mean, containers have been made developer friendly, and a whole ecosystem has emerged around them, right? So introducing a container image model, container registries, REST APIs, and command line tools with which we can manage containers, right? So part of the reason why containers are so popular nowadays is that they solve the classic, but it works on my machine problem that we've all known and suffered. But that's not quite all there is to containers, really. I mean, the containers offer this lightweight form of virtualization that allows us to wrap up our applications along with their execution environments, right, in these small self-contained deployment units that can run virtually anywhere, be it in the cloud, in all its different flavors, or on the edge.
Okay, and if you allow me to add something there, containers has also changed the way we approach security. Traditionally, we have the application security assessment that could take months, and today with the current tools we have available, we can start working on fixing security issues even before writing any line of code.
Okay, so before we start diving into some of the topics, let's have a couple of survey questions. And in our first question, which is actually a little two-parter, we want to understand how everybody out there is using containers or what their roadmap to getting to containers is.
All right, let's hear it from the audience. I'm excited to know about their container adoption journey. if they have indeed started adopting containers, and also I want to know where they are running their container-based workloads, or where they're thinking of running their containers-based workloads. So let's see what the answers are.
Yeah, while we're waiting on those answers, Alex, why don't you talk a little bit about, in particular, using containers, in the cloud versus maybe at on-prem, because that's one of our second parts to it that may be a little bit different.
All right. Later during this talk, we'll talk a little bit about the security aspects of running containers either in the public cloud or on premises, right? I mean, the good thing about containers is that they allow us to wrap up the applications in this consistent deployment model that we can. I wouldn't dare to say effortlessly, because it requires work, obviously, but we can easily deploy across different cloud providers and different flavors of cloud, be it private or public, right? And I mean, the way we develop new applications nowadays has been definitely shaped and revolutionized by containers. So thanks, along with containers, and in a big part thanks to containers, came the notion of cloud native applications, right? So cloud native applications are made up of small, loosely coupled systems, right? Which are designed to be both resilient and scalable, and like I said before, to be able to run in across different types of environments, these modern environments, such as public, private, and hybrid clouds. And they provide a consistent management experience across these environments. And we'll talk a little bit about the importance of Kubernetes on providing this consistent management experience I'm talking about.
So do we have those questions? Yes, there we go with the answer. So we have more than half of the people who are running multiple containerized workloads in production. That's absolutely awesome. And then the rest of it is split between, being in development and tests, barely experimenting, and considering, which I can completely understand. And this is a perfect place to start getting your feet wet in understanding where to do that. A third of the people are in a single cloud provider, but it's really interesting that, over 40% have some combination of, hybrid, whether it's multi-cloud or whether it's, cloud provider and on-prem. That gives us a really nice distribution to talk about, how to use containers and the usefulness of it.
Definitely, yeah. Thanks to everyone for answering that question. And yeah, not surprisingly, the public cloud is very popular, and hybrid deployments are becoming more and more common. And it's good to see that a lot of people is already running multiple containerized workloads in production, which well, obviously is telling us that the audience has some experience working with containers, and obviously knows a lot about the subject. So we hope to be able to expand that knowledge a little bit today as we address security concerns.
So while we get ready to dive into the heart of it, let's get an understanding with one more survey of how do you view your maturity of security of your containers?
So while we wait for the audience to answer this little survey, I'd like to talk a little bit about the role of DevSecOps, and more importantly, the role containers play and the importance of containers for basically thinking of security as more of a business I mean, traditionally, security has been viewed as a business inhibitor, right? Slowing down developers who want to deliver new applications and features in the fastest way possible, right? So the DevSecOps approach acknowledges this fact, and it seeks to turn security into I would say, business accelerator by embedding security into applications and their build and deployment processes, of course, right from the beginning. So uh, the consistent delivery model offered by container-based approaches simplifies automation of security controls and simplifies embedding these practices into your process. So it also provides a common language which facilitates a more collaborative approach between security development and operations teams, right? So this is why the subject of containers pops up in most conversations about DevOps and DevSecOps, even though that they don't necessarily go hand in hand. I mean, containers are great means to the ends that DevSecOps pursues.
So do we have those results? And there we go. So 40% are at the basic level, which I don't necessarily think surprises us much. I'm very happy to see that 30% of our participants here are having some sort of active security posture. This is going to be really important as we come to and start talking about the various layers. And what we're going to do for the rest of this webinar is we're going to divide up looking at security into the 5 different layers, which Alex and Alfredo will talk about. After the first 2 layers, so start getting your questions in, we're going to stop for some Q&A and not leave everything to the end. So as you start thinking about questions, please pop them up, and we're going to pause after the first 2 layers, answer some questions, then go down, answer some more questions, and then wrap it up at the end. And that way, we're kind of breaking up our hour and our day a little bit. So with that, Alex, would you like to talk about, the DevOps teams are moving away from traditional instances. They're hard to secure. They're not necessarily really designed for the cloud. They're not optimized there. And we're moving more toward container-based environments. So what are the now unique security concerns that are necessary for deploying in these environments so that the bad guys aren't coming in?
All right, so I want to share a little something. As part of designing any system, in this case, container-based systems, you always need to think about its security implications and the practices that can affect your security posture, right? So we'll see examples of practices that should be taken into account when thinking about one security posture revolving containers. But I want to kick off the conversation by going over at a high level over a typical container-based architecture, so as to lay the basis for our discussion today. So basically, when we talk about a container-based system, we have to deploy it somewhere, right? And that could either be a flavor of cloud, like I said, or an on-prem environment, right? So at the bottom here in this diagram, we have the cloud/on-prem environment, the physical infrastructure that's underlying some layer of virtualization. So on top of that, you will spin up your virtual machines, right? Now, in a traditional virtual machine based approach, you would install your applications directly onto those VMs. That's not the case with containers. So with containers, you're gonna make sure that you equip those VMs with a minimal OS distribution design and optimized to run containers. That obviously includes a container runtime, right? And then you're going to introduce an extra layer of abstraction, which is the cluster. And instead of installing the applications directly on VMs, you will provide the definitions for those applications to the cluster's control plane, which will make sure that your applications run as intended. So it will manage the underlying compute resources for you. And as we can see there, we can have multiple applications running inside a cluster. And the cluster's control plane will make sure that the containers in which the applications themselves run are scheduled across the different nodes managed by the cluster. So that's at a high level how a container-based architecture works. Naturally, there are other components. Container images need to be pulled from registries. We have to build a tool chain around this. We will have probably a build server. We will have our code repositories, so on and so forth. But I wanted you to kind of visualize the container-based architecture, so we can now start digging into each of the components that are present in such an architecture. So I will turn it over to Alfredo to go over the different application layers we're talking about and start diving into each of them.
Okay. Before delving into the layers, I just wanted to mention the concept of zero trust, which invites us to never trust on what occurs inside the perimeter or outside the perimeter. We have to, place proper controls in place before granting access to our environment. Alex, I think you stopped sharing, but let me share my screen so we can continue.
Yeah, I just wanted people to get to see your face.
Okay, no problem. But I wanted to share this image so you can have a clear picture of what implies separating in layers a container-based application. When we analyze the containers, we must analyze their context, the application they have inside, and everything that surrounds the container. So we have the cluster that manages the containers workload, the host hosting the host, the VMs or the instances that are hosting this cluster, and the cloud infrastructure supporting this entire cluster. So I think we have a brief discussion regarding applications, and we can probably start moving to the first layer. Dorren, I'm not
Yeah,
sure.
so Alfredo, what are some of the new threats to modern applications with microservices and APIs? And how do we identify and mitigate those risks? And how does containerization help us with that?
Well, the first thing we are going to consider is the application itself. We have to protect the application from the inside. We have many different controls to apply to an application environment. And as I was saying at the beginning, we should start before even writing any code. So the first task that appears is threat modeling, which implies identifying, understanding, and communicating threats and mitigations. And this should be ideally be applied at the application design stage. And one problem or challenge you may encounter at this stage is that the application or the architecture team doesn't have any documentation. So having identified the component of the application may be difficult, and therefore you cannot identify the threats affecting those components. After that, we may consider software composition analysis, which consists in identifying the dependencies that compose an application. You may have third-party or open source libraries, and these libraries may have known vulnerabilities, or they may be outdated. So you may need to identify the most recent version with the proper patches in place. Then we have static application security testing, which is analyzing the source code, looking for vulnerabilities. We have many tools that are approaching these controls to the developers using the IDE or development environment. You can find extensions that do both the software composition analysis and static application security testing. And we also have dynamic application security testing, which is analyzing the application from the outside. The vulnerability scanners that we usually name. We can have different tools that do this work externally, and OWASP has a benchmark project which compares the result of different tools. We have many free tools, but they may require additional effort to properly identify vulnerabilities. In order to improve the results for these tools, we have different documents we can use. We have secure coding practices to complete our static application security testing. Then we have the OWASP Top 10 for web applications and the OWASP Top 10 for API. One interesting prediction that Gartner provides is that by 2022, the REST API should be the first attack vector that allows data breaches in companies. So it is something to consider. And if we want to go deeper, we have the application security verification standard that allows us to improve our controls. These tools that we mentioned, SAS and DAS, sometimes are slow and imprecise, and this is where IaaS appears. IaaS is interactive application security testing. It combines techniques from DAS and SAS, and it uses a technique called instrumentation that it analyzes the application from the inside in real time, and it does background checks like if you were doing normal testing activities.
Alfredo, how many companies are starting to use that integrated more AI sort of testing?
Well, that is something recent, but one concept I forgot to mention is RASP, which is runtime application self-protection. And this starts analyzing the application from the inside, collecting a lot of information, and that is where AI comes into play. These tools usually are libraries that are embedded into the applications, and you have sensors that interact with this AI-based application. And for example, if you have an attempt to receive a SQL injection attack, instead of giving the results or the error to the attacker, they just inform that the database is not available. So they try to give a different response to avoid exposing sensitive information.
Okay, so as we add layers, and containers is just one additional layer in here that it's gone away. We're back to it. They pose unique security challenges for everyone. What are some of the common attack methods for specifically containers that someone needs to be concerned about? And again, how might we mitigate them or figure out that they're there?
Okay, so it is important that we first understand the architecture of the components we are going to analyze. We are going to talk about Docker, which is a client-server application that has three main components. The first of them is a server or Docker daemon, usually the Docker D command. This daemon creates and manages Docker objects such as images, containers, network, and data volumes. Then we have a REST API that specifies interfaces that programs can use to talk to the Docker daemon and tell it what to do. And finally, we have the command line or the CLI, the Docker command we are commonly seeing. This command or this CLI uses the REST API to control or interact with the Docker daemon through scripts or direct commands. We have a different view here when the Docker client can interact with the Docker daemon or Docker server to create, to build and run containers. The Docker daemon is the one that distributes the containers in the different environments. They can be on the same machine or in different machines. In the case of being on the same machine, you have a direct communication. If you have the Docker daemon in a different machine, you can use either Unix sockets or network interfaces. We also have in the middle of the screen images. The images are read-only templates with instructions for creating Docker containers. And a container is an instance of an image. You can create, start, stop, move, or delete container using the API or the CLI we previously described. And on the right side, we have the Docker registry, which actually stores these images, and you can have public or private registry. And an example of a public registry is Docker Hub. So talking about the attacks, the most common attacks occur in the containers. We can consider these attacks as the common attacks on operating systems or applications. We can have buffer overflow, SQL injection. The attacker is wanting to gain remote code execution. And usually, once the attacker goes into a container, he wants to move laterally to other containers, for example. Or if we have a bad configuration, he could attack the Docker daemon. So the attacker is basically looking for persistence of this attack. And we also may need to think about attacks to the registry. Those are not attacks to the registry itself, but are kind of man-in-the-middle attacks when you intend to download an image and the attacker gives you a different image. So for this, we have the concept of Docker Content Trust, and when we use signatures to validate the integrity of the images. In order to prevent this, we have different documentation. I want to mention the csecurity.org website, where we have a lot of CIS benchmarks. These are documents that have best practices for different components of our environment. We have practices for cloud providers, database servers, operating systems, virtualization, etc. In this case, we are going to talk about the benchmark document for the Docker Community Edition. Here we have recommendation for host configuration. This includes partitions, service permissions, configuration files, and auditing issues. Regarding Docker daemon configuration, this includes network traffic restrictions, secure connections, namespaces support, among other things. Namespaces are basically a way to isolate application. You can have a group of containers running together, but you want to isolate those containers from the other applications. Then we have Docker daemon configuration files. This includes recommendation for ownership and permissions of the service. Regarding container images and build files, they recommend using trusted images, as we described, using integrity or signature verification. Avoid the usage of root, the root account when you run containers. Include only the minimal packages you need to run your application. Avoid secrets to be stored in the Docker file, etc. Then for container runtime, we have recommendations like secure Linux, using resource limit like memory and CPU, and mounting the root file system as read-only. Regarding Docker security operations, it provides recommendation to limit the number of containers you can run in a host. And Docker Swarm configuration, in this case, is optional. It's a way of orchestrate containers, but we are going to review a different tool for this.
Okay, so I'd like to open it up to some questions from the participants. I don't have any in the queue right now, so hopefully we'll have a few. While we're waiting for some questions to come, why don't we, while we're waiting on that, bring up our third survey, which is about how do you orchestrate your containers?
I'm interested in knowing about this one. I mean, I have an idea of what the distribution for the answers will be, but let's hear from the audience.
I just wanted to mention another thing while we wait. Additionally to the recommendations or best practices we discussed, before deploying a container to production, we may want to analyze as well, to perform a static analysis over the image, because many of these images have known vulnerabilities. For example, we may have a Node.js image based on Debian that may have vulnerabilities. And if we analyze a different image based on Alpine, we may find that they don't have any vulnerability. So we have to choose a correct image for the container we want to deploy.
Well, so far we still haven't gotten any questions. So here's our polling results. I don't think Alex, Alfredo, or myself are surprised that 64% of people were using some sort of managed Kubernetes.
I'm surprised to see. Yeah, sorry, Dorren. Yeah, I'm
okay,
kind of
go on.
surprised to see that nobody's self-managing Kubernetes. I mean, I expected that most people would be using some sort of managed Kubernetes solution, but it looks like we have a strong preference towards managed solutions by cloud providers. And well, it's a shame we didn't include more options to see what other orchestrators they're using, since 28% of the audience today is using some other container orchestration technology that such as Docker Swarm, Nomad, it might be something like Mesos, but yeah, not surprisingly, most people nowadays, most companies are resorting to managed Kubernetes offerings, and I would guess that if we were to drill down into that option, we would find that most people are using EKS. So according to recent surveys, around 80% of container-based workloads running in the public cloud are running on AWS, and EKS is a service that has become extremely popular over the last few years.
Okay, we still don't have any questions, so why don't we just kind of plug away and go to our host and VM security, going our next layer down. We've been securing instances for years. How does now not only containers, but the move towards serverless containers change our security practices?
All right. Well, I'm glad that you brought up serverless, Dorren. I've witnessed a lot of debates on serverless versus containers, as if they were two opposing technologies, and they really aren't. I mean, I guess this is probably because serverless has traditionally been associated with function as a service offerings, such as AWS Lambda, for example. But serverless is much more than that, and in fact, serverless and containers can work very well together. So serverless is this cloud computing delivery model in which the cloud provider dynamically allocates resources that you require to run your workload without you needing to provision or manage any servers or compute infrastructure. So this brings about a number of advantages, right? Your workload automatically scales up or down. There's little to no over or under provisioning. The cloud provider makes sure your workload is highly available. And like I said, you don't need to manage servers. And I would like to include the notion of securing servers in the concept of managing. I mean, managing infrastructure, managing servers involves securing those servers. So the good thing about serverless offerings, and in this case serverless containers, is that you don't need to worry about provisioning these virtual machines that should be as slimmed down as possible to include only what's necessary to run the containers. On top of it, you don't need to harden them. You don't need to patch them over time. So in this way, you can free up time for other business differentiating activities. I mean, your engineers will have more time to focus on developing new features, retiring technical debt, so on and so forth. So that's the biggest advantage of serverless in general and serverless containers in particular. So cost and security are usually the main concerns companies raise when discussing the possibility of running serverless containers. And along with security, companies usually raise compliance concerns as well, right? So, and these are actually long-known concerns traditionally raised by companies that are somewhat reluctant to make the move to the public cloud. And I don't want this. I mean, I understand reluctancy, and obviously careful analysis should be carried out whenever considering a move or migrating a workload or developing a new workload in the cloud. If you're used to an on-prem approach, but public cloud infrastructure are designed to address a lot of regulatory and compliance requirements. So public cloud providers invest a lot of money on cybersecurity research, and they put in a lot of work to ensure strong safeguards are in place to preserve customer privacy and to segregate their workloads. So serverless containers offerings in the public cloud are secure. And take the example of Fargate, which is perhaps the most popular one, is the serverless containers offering by AWS. So Fargate tasks and the containers within those tasks run in their own dedicated kernel runtime environment. So that means they don't share CPU, memory, storage, or even network resources with other tasks. So it ensures isolation by design. It allows you to further refine security capabilities, and it also provides tight integration with services, native AWS services for logging, monitoring, and secret management, for example. But and it's one thing that I would like to point out is that it's also compliant with several regulations. It's a service that's compliant with PCI DSS, SOC 1, SOC 2, and SOC 3 compliant. It's HIPAA eligible, so if you have a protected health information workload in your hands, you can safely deploy it to Fargate. So and there are even U.S. government regulated workloads running on Fargate. So Fargate is a secure service. Other cloud providers offer secure serverless container services as well. So there's no need to worry about security in that sense. Obviously, you have to take some precautions that when running your workloads on top of such platforms, but that's something that is inescapable. You have to do it anyway, regardless of where you run your container. The good thing is that all the tasks that you use to need to carry out to secure your hosts, and Alfredo will give some examples of those tasks now, are gone. I mean, all that heavy lifting is gone with these services. So Alfredo, a few words on that?
Yeah, let me first talk about the cluster that we left pending. When we think about Kubernetes, as we did with Docker, we also may need to consider its architecture. We have on the right side the Kubernetes worker nodes, which is the component that actually runs the workload. The worker nodes are either physical or virtual machines that run these containers. They have the minimal unit that Kubernetes used to run a workload, which is a pod. A pod can be composed of one or more containers. These worker nodes have an agent called the kubelet. This kubelet monitors the health of the containers within the pods and can start or stop a container when they have any issue. And then on the right side, as we were discussing, many of you are using managed Kubernetes. In this case, you may not consider this component when you have a managed instance, but in case you run a workload in a self-hosted environment or a fully managed Kubernetes instance, you have the control plane, which is the managed and distributes the workloads to the worker nodes and the pods. And it does this through the Kube API server. And it also has an important component, which is etcd, which is a key value store that stores the state of the cluster. You can have everything regarding the cluster store here. So the attacks most commonly occur on this component. If you have a self-hosted Kubernetes instance, this usually by default comes without certificate and without requiring authentication. So it may be the first attack vector for Kubernetes. Then if you think of a container that is not properly protected or vulnerable, you can have access to it. And if every container has a token as a way of protecting your information, and if that token doesn't have properly configured airbag, which is role-based access control, you can gain access to the kube API server and therefore control the entire cluster. Additionally, we may want to protect the kubelet, which is the way we have to handle workloads within a worker node. And we will review some best practices for that. So as we had for Docker, we have also a CIS benchmark document for Kubernetes. And we have configurations for the control plane components. Here we have configurations for the master node, for the API server, the controller manager, and scheduler. etcd is basically putting authentication and certificates in place to protect this component. Control plane configuration refers to authentication, authorization, and logging. Worker nodes, we have configuration for the files itself within the worker nodes and the kubelet. And policies include airbag, which is role-based access control. We have service accounts. We have pod security policies that establishes restrictions to run pods, network security policies that limit network connections, and secret management. So far we have reviewed a lot of configurations and best practices, but even if we have a perfect plan for those configurations, that plan can fail because we are not considering everything. Fortunately, this blog post from Microsoft provides a Kubernetes attack matrix based on the Mather attack framework that you can use to explore the attack vectors over Kubernetes, going beyond those recommended configurations. Okay, going to host, assuming
wait.
that...
Alfredo,
yeah.
1 second before we go there.
Sure.
Bob has a question of what are the main differences between managed Kubernetes solutions like EKS versus the others? Great question.
Great question
Yeah.
from Bob, right?
Yes.
Thanks, Bob, for that question. So that's a great question, and I'll take it, Alfredo, if you don't mind. An important component of Kubernetes, the Kubernetes architecture, is a control plane, which is basically what the brains of the cluster, right? It's what takes care of allocating containers in the underlying nodes, managing those nodes, and basically making sure that the desired state. Sorry, I heard something. Making sure that that the current state of Kubernetes is always up to date according to its specification, right? So the problem is that managing that control plane, so the control plane runs on some special nodes that are called master nodes. And in order to ensure a high availability of your system, you have to ensure that those master nodes are replicated, right? And that's, I mean, that sounds simple in concept, in theory, but it's not that easy, really. There's a lot of things to take care of, and basically, without the brains, your cluster is headless. So if you need to deploy a new application or an application, I mean, a container running an application suddenly has an error or something like that and needs to be restarted, and you have the brains running all that. Basically, like I said, you're running headless. You won't be able to bring the cluster to that desired state. So like I said, that requires replicating those master nodes in order to ensure that your control plane is highly available. Which brings me to managed Kubernetes offerings. So the main reason why people use managed Kubernetes offerings is that they handle the control plane for you. They provision the master nodes for you so that you don't have to do all that work by yourself. So they ensure that your control plane is always available, well, or available at least according to some SLA, and you only worry about well, in some cases you manage the worker nodes, which is where the containers run, your applications actually run. In other cases, there are offerings that also manage the worker nodes for you. So you just basically worry about talking to Kubernetes, and they run it for you. Do we have any other question?
We don't right now.
Okay, let me continue with the hosts. So as Alexis described before, in case you don't manage, you don't want to manage VM or instances, you may need to, you avoid worrying about this, but in case you are running your VMs or instances, let's assume that you are using Ubuntu, which is the document I'm sharing here. You may need to consider these different stages. For initial setup, you have configurations files for the system, updates. You have recommendations to use sudo to avoid the indiscriminate usage of the root account, startup configuration, and hardening recommendations. Regarding services, it is mostly for special purpose services like the time synchronization and suggestion for disable unused common services. Regarding network configuration, you have to review which hosts are allowed or denied within your environment, ensure that uncommon network protocols are disabled, check the firewall configuration, among other things. Regarding logging and auditing, you may need to ensure that logging is enabled and protected, and the data retention period is adequate. Regarding access, authentication, and authorization, it provides recommendation, to configure cron for scheduled tasks, SSH, user accounts, etc. And regarding system maintenance, you have identifications of files with excessive privileges, configuration of user files and passwords, among other things.
Okay,
Right, so,
we have 6 minutes left to go. So Alex, Alfredo, I'd like you to give us some closing thoughts before myself and Dennis kind of wrap this up.
Yeah, if you allow me, I would like to share briefly the last layer we have, the cloud provider, the cloud infrastructure.
Okay.
Let me briefly describe that. So basically, we have CIS benchmark documents for each of the 3 main cloud providers. They share some sections in common. Let me briefly describe them. For example, identity and access management talks about if you have a password security policy in place, if you are requiring multi-factor authentication for your privileged users, if you are rotating your credentials for programmatic access, if you have your users in groups with minimum privileges, if you have roles defined for each of your users. Then we have logging and monitoring that, you have track of the API calls in your environment. You have registering your applications, centralizing the application information. You have to define metrics and alerts, and you can trigger events that, trigger alarms and events that are addressed by serverless functions to automatic remediation. Regarding networking, is basically how you protect your cloud resources. If you are allowing access from anywhere, if you are exposing ports that should only be accessible from your company's facilities. Regarding storage, you may need to check if your buckets are publicly accessible, if you have encryption in transit and at rest. And between Azure and Google Cloud, you may find some difference in recommendation for databases, storage, virtual machines, and specifically, AWS has two different benchmarks. Each of the cloud providers have their own version. AWS has two. One is for fundamentals and the other for three-tier web applications. And meanwhile, Azure and Google Cloud has more complete versions of controls.
Yeah, so to expand a little bit on that and kind of wrap up the idea, I mean, it's very important. The security of the environment where you're running your containers or any application for that matter is very important. And speaking about the public cloud in general, so security incidents involving the public cloud are usually due to misconfigurations, right? And misconfigurations are often caused by omissions, right? So engineers forgetting or not having enough time or not realizing that they should apply a certain policy or restriction. And those benchmarks Alfredo just mentioned kind of summarize and provide a great list of checks that you can go over either manually, but preferably automatically, and there are tools for that. So you can verify that for the most important services and the most common configurations that you can come up with in the public cloud are secure. So that you don't leave, any sort of a service that you shouldn't expose to the internet. So for example, S3 buckets on AWS is a very common case of exposing private files to the internet due to making the bucket public. And another one is, for example, expose database ports to the internet. They don't need to be exposed to the internet. So those kinds of things are the issues we most commonly see in cloud-based environments, and running these kind of benchmarks, make sure that you don't miss those kind of things and that you don't realize about them when it's too late.
Yeah, and as a final thought, I would like to recommend, separating the layers of your applications, analyze them separately to identify threats. You have those documents already available, so you don't have to think about the minimum recommendations you have to apply, the minimum controls. You have to centralize that information in order to take immediate actions. And you have to share that information within a team as soon as possible, because as Alexis mentioned, most of these attacks are based on misconfigurations.
So Alex and Alfredo, I would like to thank you for your knowledge today and sharing it with everyone. I would like to thank David from Dynatrace. I would also like to thank Crumbling Group. Both of these companies have been long sponsors of DevOps. I would like to announce that this is going to be the last independent DevOps Society event. We are going to be merging with Cloud. DevOps has been around as a society for almost 10 years. And Cloud has been around for, I think, about 4 years. And it's the right time with COVID and everything else going on for our two societies to merge and become one. And hope that everybody here will start attending and joining, if you haven't already, many of the Cloud events. And with that, Dennis, I'm going to turn it back over to you.
So thanks, Dorren, and thanks, Alex and Alfredo, and thank you, Dave, for your support. Really enjoyed it today. I know it's a very narrow subject, but very important one. Again, we would like to offer to our audience the possibility of providing them with a free cloud assessment for their container-based environments and cloud in general in reality. So thank you for presenting Dorren and the team, and thanks to the Technology Association of Georgia for their continued support of our society and as we merge on with cloud. And again, thanks to Dave from Dynatrace. Thank you for your support. And please stay in touch. If there's anything we can help you with through the assessment or just answering some questions, we're here for you. Thanks, everyone. Have a great day.
Thank you.
Thanks, everyone. It's been a
Thank you.
pleasure and an honor. Have a great day.
Have a great day.